the opponents say that therapeutic cloning and reproductive cloning can go hand in hand and there are two different issues. Well, okay, let's imagine this hypothetical situation. A scientist creates a cloned embryo but lets it grow near the fetus stage. That would be reproductive cloning, which is not allowed. Then the scientist kills the clone by extracting whatever remaining stem cells are left, killing the fetus clone. Now it is therapeutic cloning. What did the scientist just do? He accomplished two things. One, he extracted stem cells and he successfully cloned an embryo near the fetus stage. Which type of cloning was it? Therapeutic or reproductive? Technically he did both, but he can be excused of the reproductive cloning because he extracted the stem cells of the clone. This is a problem that could be faced when you allow therapeutic cloning. Another thing Megan said was that a mouse was healed from Parkinson's disease. Yes, this is a great breakthrough, but you can't relate a mouse to a human. Mice and humans are completely different species. According to Nicholas Wade of the New York Times, he states that you can't assume that just because a mouse was healed, it can be the same for people. That's just like saying whales and humans are both mammals. We are both warm-blooded. We both have fur, and pretty much we're almost the same. But whales can hold their breath for at least 30 minutes, so I'm going to try and hold my breath for at least 30 minutes underwater. The two don't match up, so to say it works is incorrect. Yes, it did cure Parkinson's, but not of a human. The only way it'll work is if you actually try it on a human, but then that'll result into a human experiment. To summarize the negative side, we are not denying that there is an organs list, or that there are infertile women, or that there is a problem. We are here to say that cloning is not the correct approach, and if it were to be allowed, more problems will arise. Thinking that it can heal everything and cure everything is wrong. In fact, the National Human Genome Research Institute states many researchers think it's worthwhile to explore the use of embryonic stem cells as a path for treating human diseases. However, more experts are concerned about the striking similarities between stem cells and cancer cells. Both cells have the ability to proliferate indefinitely, and some studies show that after 60 cycles of cell division, stem cells can accumulate mutations that could lead to cancer. Therefore, the relationship between stem cells and cancer cells needs to be more clearly understood if stem cells are used to be treated to humans. Now, with this information, would you really want therapeutic cloning to extract stem cells to possibly heal humans, but it could also lead them to cancer? It's just a cycle. It just cancels each other out. There's too many uncertainties in therapeutic cloning, and there's too much speculation. In a final quote, Thomas Okarma, chief executive of Geron Corporation, the leading stem cell research establishment, estimates that it takes 100 eggs, if you're lucky, to produce a usable stem cell line. This means that if a cure for diabetes involving therapeutic cloning is found, it will take 1.5 billion eggs to cure 15 million Americans who have diabetes. Until the production of stem cells become more efficient, few cures could be made for economic reasons. Even if when these techniques are found, reliably produce one stem cell for each egg harvested for a woman, 15 million eggs would be required to completely wipe out diabetes. Extracting eggs from women is painful and costly. Do you really want a proposition that seems highly improbable to be allowed? Do you want this potential proposition that could harm women, kill off a living organism, not potentially human or not, and to cause economic trouble for patients and for biotech companies to be allowed? For us, we don't think so, and that there are more simple alternatives than just therapeutic cloning.
So throughout the debate, we've heard many good points from